theta d theta. So under that substitution, we would now have integral dt secant theta tan theta d theta over, well, tan squared minus 1 is secant squared minus 1 is tan squared squared. So tan to the 4. So that's integral secant theta over tan cubed theta d theta. Secant is 1 over the cosine. Tan cubed is cosine cubed in the numerator. Well, we have tan cubed in the denominator. So the sine cubed stays down here. The cosine cubed goes up there. So let's go ahead and do it on our scratch paper. We have secant theta divided by tan cubed theta. So that's 1 over cosine theta divided by sine cubed theta over cosine cubed theta. So 1 over cosine theta times cosine cubed theta over sine cubed theta. And cosine squared theta over sine cubed theta d is what's going to result.
Wait,
Did I do that right?
yeah.
Okay. So this turned into secant, well, that turned into that. Cosine squared theta d theta over sine cubed theta. Now what are you going to do? Didn't work out, did it?
You can change cosine to
Squared.
to 1 minus sine theta.
And then you're in
And then you
the
can
world.
split the fraction.
So 1 minus sine squared over sine cubed. So 1 over sine cubed is cosecant cubed. Uh-oh. That's just as bad as secant cubed. And you may not have the formula memorized, and you may not have a table available, so get ready to do a bunch of integrations by parts. Minus the integral, well, d theta, minus sine squared over sine is 1 over sine, which is just cosecant, and that one is not bad. So this works, right? That one's not a very nice one. Let's go ahead and see if partial fractions is an advantage. So if you're going to use partial fractions, you're probably going to rewrite this as integral dt over t minus 1 times t plus 1 quantity squared. Or in other words, that's the integral of dt over t minus 1 squared t plus 1 squared. Well, partial fractions, huh? Partial fractions, I'm going to take 1 over t minus 1 squared t plus 1 squared. And I'm going to rewrite that as some constant over t minus 1, some other constant over t minus 1 squared, a third constant over t plus 1, and a fourth constant over t plus 1 squared. So at this point, you may be preferring this, but again, this is no fun, right? Going to fill up the whole board there.
I have a question. How do you know when it's the bx plus c over?
When it's a quadratic. Quadratic. See, we want to form proper fractions. Now, see, so really, I mean, if you combined these two, think about it, what I would do here, it's really a very good question. If I were to combine these first two fractions, notice that you get at minus a plus b. In other words, adding these two together keeps it a proper fraction. And we just, through our previous work in college algebra, have realized that it's easier to take this proper fraction and break it into two of them like this. So this really is a linear, a t to the 1 over a t to the 2. It's just been broken down into something a bit more convenient. Okay, so now I'm going to multiply both sides by the LCD. T minus 1 squared, t plus 1 squared. And so we get 1 equals a times t minus 1 t plus 1 squared plus b times t plus 1 squared plus c times t plus 1 t minus 1 squared plus d times t minus 1 squared. Given my track record today, I'll stop for a moment and let you check that for errors. Well, I can choose any value I want for t. The left and the right have to be equal. An equal mark is a very strong statement. So I'll choose t equal 1. Then I get 1 equals, well, that's 0. That's 4b. That's 0, and that's 0. So b is 1/4. Let's go ahead and put that in there.
How'd you get a t minus 1 t plus 1 squared? Shouldn't it be like a t minus 1
Well,
squared?
one of the t minus 1's cancels.
Oh, okay, okay.
So a t minus 1 remains and both of the t plus 1s. Questions? Am I doing okay so far? Now I'm going to choose t equal minus 1. So 1 equals, well, 0. T is minus 1, that's a 0. That's a 0. D times 4. So D is 1/4. Let's go ahead and change that. Well, it doesn't do any good to choose t equal 1 or t equal minus 1 again. That would put zeros here for the a and the c, and then we'd never find out what they are. But I can pick any value for t I want. How about if I choose t equals 0? That's an easy one. If I choose t equals 0, then I get 1 equals minus a
Plus B.
plus a 4th. I agree, plus b, but we already changed b into a 1/4. Remember 0 here, so plus c plus a 4th. So I get minus a plus c equals 1 minus a half. Or maybe I should write that as minus 2a plus 2c equals 1. So I'm going to get 2 equations and 2 unknowns, and I'll tell you what a and c are equal to. Well, I've used 1, I've used minus 1, I've used 0. Yeah, it's the next nicest, huh? 2. And I haven't used black here, so t is 2. So 1 equals, well, let's see here, 2, so that's 9a. 2, so 9/4. Once again, t is 2, so that's 3c. And plus a 4th. So now I get 9a plus 3c equals 1 minus 10/4 is 1 minus 5/2, so that's a minus 3/2. Is that right?
Yeah.
So 18a plus 6c equals negative 3. And now I'd multiply the top equation by 9. So I get minus 18a plus 18c equals 9. Positive 18a plus 6c equal negative 3. So 24c is 6. C is 1/4. Now that I know what c is, I can plug that back into one of my original equations. So minus a plus c is plus 1/4 equals a half. Minus a is minus a 4th. And so a is all, so everything's 1/4. Is that right? Everything's 1/4. So in other words, I've now changed this integral into, let's just factor out the 1/4. So I've got 1/t minus 1 plus 1/t minus 1 squared plus 1/t plus 1 plus 1/t plus 1 quantity squared. The calculus on this problem is now very easy. Right here, what I did is easy algebra, difficult calculus. Over here, what I did is difficult algebra, easy calculus. So 1/4 the quantity. Well, there's ln absolute value t minus 1. That's minus 1 over t minus 1. Right, because the derivative of minus t minus 1 to the negative 1, what's that? Well, the minuses cancel, so t minus 1 to the negative 2, I get 1 over t minus 1 squared. Plus ln, absolute value t plus 1, plus, minus 1 over t plus 1, plus an arbitrary constant. Oops. So, which method do you use? That is totally up to you. Calculus is bad, the algebra was non-existent, the algebra was bad, the calculus was still existent. Not that easy, but a hell of a lot easier than cosecant cube. And that board, that took up the whole board. I gotta wait till you guys are done copying before I can erase anything. I bet I can write the original problem here on the next one. I can get rid of that. So I'll still answer your questions. I'm just giving you a minute to formulate them while I'm copying down 23. I have no idea. What did I do? Is it? Let's pretend that it wasn't. Let's see. Yeah, it was. Yeah, it was 1/2. But pretend that it wasn't, because it's not going to make that much of a difference. And didn't that come out nice that way? 23. 10 over x minus 1 and an x squared plus 9. So this one we see right away, right? We don't want to try trig substitution on that. The x minus 1 doesn't lend itself to a trig substitution. The x squared plus 9 does. But that doesn't do us much good with that x minus 1 there. Now there's ways we could force that to happen. We could substitute t for x minus 1. And then we would end up with something here that we could do a trig substitution on. So we could make that work. However, it looks to me like it might be a lot easier to rewrite 10 over x minus 1 times x squared plus 9 as a over x minus 1 plus b x plus c over x squared plus 9. There's where we know to do a linear on top because the denominator is a prime quadratic. Multiply both sides by the LCD. And we get 10 equals a times the quantity x squared plus 9 plus bx plus c times the quantity x minus 1. So there's really two easy to get values here. Obviously, we're going to let x equal 1. Then we get 10 equals 10a plus 0. And so a is 1. And let's everybody check Larry's arithmetic and not wait till the problem's over. Well, now the reason I want to choose x equals 0, aside from the fact it's the easiest to work with, is that that will kill the b. We already know what a is. I'm now going to find c. So I'm going to replace a with a 1, which just means to erase it, huh? So let's let x equal 0. Then I get 10 equals 9 plus c times negative 1. So c is equal to negative 1. And again, check my arithmetic because I'm an idiot, as you've seen over and over. Now that I know that c is negative 1, I'm going to go back and change plus c to a minus 1. So now notice there's only one unknown left here, b. Pick any value of x that you want. When you substitute it in, you're going to find b. So I think probably minus 1 is, I don't know, 2 is okay. Let's just use 2 because then that becomes a 1. So let's choose x equal 2. 10 equals 4 plus 9 is 13 plus 2b minus 1 times 1. So plus 2b minus 1. what's that? This is a 12 minus 2b is a negative 1. Now what? Now quit playing around with algebra, Newberry, and do some calculus. So we have just discovered that this can be rewritten as the integral of a over x minus 1. So 1 over x minus 1 plus, or should I say minus, b and c are both negative, so let's factor out the minus 1. X plus 1 over x squared plus 9 dx. Well, that second integral I'm going to write as two fractions, or two integrands, 1 over x minus 1 minus x over x squared plus 9 minus 1 over x squared plus 9. Well, the x minus 1 we're ready to integrate. The x squared plus 9, we're actually ready to integrate if, when you did the reading on 7.1? No, it was back in chapter 6, I believe. Didn't they tell you? Yes. If you'll open your books to page 480, any of you could have used this formula on the test. Of course, you had to read the book to know it was there, because I didn't tell you. But the book on page 480 says the integral of dx over x squared plus a squared is 1 over a inverse tan x over a plus an arbitrary constant. So if you had bothered to dig up that formula, you'd realize that, well, this is already done. A is a 3. So really the only thing you have to do is the middle integral. It's u sub, isn't it? X over x squared plus 9 dx. You're going to let t equal x squared plus 9, so 1/2 dt is x dx. So that becomes the integral of 1/2 dt over t, which is 1/2 the ln, the absolute value of t, plus an arbitrary constant. So now that we know that, the integral of 1 over x minus 1 is ln absolute value x minus 1 plus, or excuse me, minus 1/2 ln, and t here was x squared plus 9, which is why we get to leave off the absolute value, because x squared plus 9 is always positive, minus, and if we're going to use this formula, 1/3 the arctan of x over 3, all plus an arbitrary constant. And if you don't know that formula that the book really was expecting you to memorize, but I did not force it, then of course you have to do, factor out the 9, make a substitution.